Okay, we're going to finish chapter 4.2. Um, chapter 4.2 is related to 4.1 about the idea of correlation between two variables and how are they related. Um, and in this class, we look at data that is linearly correlated, meaning that when you plot the points, like we did on the previous lesson, wherever that is, the previous lesson, the points kind of form a line. And when they do that, we say they're positively correlated or negatively correlated. Kind of looks like that. And remember, we measure correlation using the correlation coefficient value. And these are examples of that. And we'll do some more in class. Um, we ran what's called a regression analysis, simple linear regression analysis, and we got some important information to determine if those two variables were correlated. Do we think there's a relationship between the explanatory and the response variable? And so that's where we left off. So let's pick up with that. And so the first thing that we're going to learn to do is what's called calculate the least squares regression line. Another word for that is also, so we have this one right here, least squares regression line. And another word for that you might have heard is line of best fit. Line of best fit. You also may have heard um, line of best fit, or another term where you're going to hear me say is called, it's the regression equation, which is just I'm going to not say least squares, the regression equation. And so that's what we have. That's what we're doing here. So here's the situation. Here's that same data that we had before. Instructions: find a linear equation that relates these two variables. So we did this in algebra class, Math 83, but we wrote the equations by hand ourselves. And now what we're going to do is we're going to have the computer stat crunch. We will use technology, right, to determine that. And so we think there's a relationship, which we already know, between how far a ball travels and how fast the club, the stick, the golf club that we use to hit it with. And so then we can use that to make predictions. So let's go ahead and show you how to do that again. And I have the instructions right here, but we'll go ahead and do that now. And so in StatCrunch, we have the data right here, and this is the one we're interested in right here. So we're going to go ahead and I'm going to run a regression, simple linear. The x variable is the speed of the club head. The response variable is the distance that the ball travels. And then we go ahead and compute. And then we get these values right here. And so we have some important values that we're looking at. We're looking at this information right here. And so looking at that information will tell us, um, again, if we have correlation, which we've done before, and then the graph will come up too. So I'm going to put those in place over there so you can see the relationship. And so we have the graph and the equation. And so let's put that into our notes. I'm going to go ahead and clip that in real fast. So it looks like we have this already here. So we have the equation right there. And then after that, I'm going to go ahead and put the graph in there because we had the graph. Sorry about that. We can get that taken care of here. That's what we had put into place. Put it in. So there is the results of the simple linear regression. So we have that. And then right here, what you will see in this, where it said find a linear equation right there. Remember from algebra linear equations, y equals mx plus b. That's a linear equation. That is technically right there. That's where you would find the equation. The equation that we're looking at is right there. The x value this is your x value, and this is your y value. So distance is equal to some value, in this case negative 55, 0.70966 plus 3.16. So this is related to each other where we have some values here. So for part A, the equation is distance is equal to, and I'm going to abbreviate 0.5796. I'm not going to write the the entire word out. 66. And then club head, that was our C. And so there's our variables. We put that in different colors so you see there's your C and your D right here. That's your X and your Y value. So you can kind of see it looks like your MX plus B. We're just using different variables. And then what does the graph look like? The graph would look like this here. There is a sample of the graph. The line there is the equation of the line, which we had graphed in Math 83 or in algebra class. And that would have been used on Desmos if you recognize that that's what we would have used. I'm going to put that in so we can have that together. So we have that here, and then you would put that in. We would put that in there. Let me get that. There we go. So there's the graph of this data plotted, the scattered graph, the scatter plot, and then the equation that goes with it. And then we can answer some questions here. Let's find it. There it is. So the questions is now graph the line on the scatter diagram, which we've just done. There's the line. StatCrunch will do that for us. So we've done part B. Part B is right here. Part C, use the equation to predict the distance a golf ball will travel if the club head speed is 104. So what's asking us now is, if we had a value of 104 right here, what would the distance be? So if the club is equal to 104, what does distance equal to? Distance equals to what? And so to answer that question, part C, what we do is just substitute in there. Distance would be equal to negative 55.79661 plus 3.166. And then instead of C, we're going to plug in 104 in there. So that is what gets substituted in there, 104. That comes from the question here that said, predict the distance the club head will travel with the speed of how far the ball will travel with this club head speed of 104. You just plug that in, and then we calculate that. Okay, so we plug it in, and then we get an answer of D is equal to, after you calculate that, 273.467. So we would then say that it travels 273 feet. That's what we would be saying. And that's how we use the equation to make a prediction. And so now with that in mind, we would answer the next question, which is find the residual. Now that's a new term that we need to define for you real quick. And so residual, which is here, the difference between the observed value of y and the predicted value of y is the error or the residual. So we're trying to find, so there's a new term. Make sure you get that in there. Okay, so now that we know what a residual is, it's the difference between the observed value, the value that you have in your table, which is the observed. That would be the observed is, this is from the table, and the value of y, the predicted value, and this is from the equation, the regression equation. So you look to see how close your prediction is, and that's your residual, the observed minus the predicted. So the residual equals observed, what you get from the table, observed minus predicted. And so the question here, we'll find the residual of the club head speed with 104. Actually, I want to change it to 103 because we don't actually have this is only a predicted value. So let's make an adjustment on this real quick. This is 103. And so we're going to then part D, we're going to use club head equals 103. And so the first thing we want to do is find the predicted value. How do we find the predicted value? What's the predicted value? You go ahead and use the equation again. So we say D is equal to negative 55.79661 plus 3.166. And its place, we're going to go ahead and put in 103 to find the predicted value. The predicted value for that, I have the calculator real quick. Predicted value is equal to, in this case, 270.30. That's the predicted. Now we need what's called to find the residual. Right, we need the observed. The observed value comes from the table. And so we look for the club head of 103 in the table. We see the predicted is 274. Or I'm sorry, the observed is 274. That comes from the table. And then the residual in this problem then, the residual is the difference between those. How far off is the prediction? That's all a residual is. And so it's the observed, 274, minus the predicted. And so when you subtract that, you get a residual of 3.70. That's your residual.